Channel's flying saucer.
Okay guys, so what I'm going to do here is show you graphically what we're gonna do on this coming video. Let's say this is our motor here, and this is the center shaft. So the way we have it set up, we got a coil here, and we have another coil here, which is identical to that one. And the way that we have it, it's configured, it's plus and minus and minus and plus. So this revolves, and this, let's say, is L1 and this is L2. So we know that when they revolve around this shaft, L1 gets the battery, say we put it right here, battery's right here, and close the connection here. We got a plus and a minus on the battery, and yeah, battery. So once that we feed this coil L1, it gets magnetized, then it swaps and it goes to L2, becomes in the position of L2, but it reverses, and this is our output here, right? So, and this motor we have here has 5 poles, and it's a 5 pole, and it's got 5 pairs, so it's got 10 coils that actually add 5 pairs. So each pair will be an inductor, or L1. So we got L1 to L5 here. When we look at this, what we're gonna do in this video is connect caps on the side of the motor. And the way we do this, the super caps will be here, will be one, and say right here will be the other one. And this is C2, Now C1 will be right here, and this way and this way. Okay, so we got C1 and C2. Now, how they're gonna get charged, and they will, and you'll see it on video. We inject battery plus minus here, and they receive half a charge. But when L1 becomes L2 position, it reverses and does like a mirror to L1. So it charges the other end while we keep charging the other one. So what we're doing here is we are charging these two capacitors just using half of the battery power. That's why we can achieve faster values of charging, because what is actually the collapse of the coil of L2 is what is doing the other percentage of charge, while the battery is only doing a 50%. The other 50% gets done by the collapsing coils. Now, it is understood that if we have more coils and more pairs in the thing, it will get better and smoother. But this is the point right now. We're going over the 5-pole. And what we saw on the first video was a cap that we had connected right here. Another cap. So that was on the first video. But on this video, we're only going to have C2 and C1 connected on the side. And why I call it crossfiring? Because they are connected, they are actually not directly connected like this cap is. This will be C3. Now, C3 is connected completely parallel to creating an LC circuit in parallel with this cap, with this coil, L2 and C3. So C1 and C2 are not directly connected, but only halfway. They are like series connected within the system. But if you open the loop here, it'll they'll stop charging. If you open the loop on this side, it'll stop charging also C2, because the series will be open. But at the same token, you got to realize this is a moving platform here. This is constantly moving and revolving here. So we have a motor in there and a generator that is doing the job of replacing constantly and gaining speed, because of the previous video that we saw in first video, that C3 keeps the motor running and assists on the rotation and on the acceleration and on the battery regeneration. So we'll go to the video next and we'll see everything in real life, in real lab testing. Thank you. Okay guys, so here we have the caps, two caps set at each side of the motor, and each that meter right there is showing up the amount of charge that they have. I brought them down to a pre-charge of around 250, 240 millivolts, and that one in the center of the X-Tech, the yellow, the orange ones, is showing this one, and the end one is showing the battery value, which is 2.705. Now, tachometer is already on 0, and the meter, the DC clamp, it's also set up at DC amps and reset to 0. So we're ready to go. Roll a test. And I have to tell you that this, I just disconnect it here a minute to show you. I have to add some soldering and some extra cable here because it kept getting hot. And actually, now it's pretty tight, and I hope that will avoid, because I was losing a lot of energy on on heat from the small connector that comes from factory here. And I hope this will hold on through the complete test. And this is a proof that, yeah, previous battery holders that I have used had the same problem. They're not designed for this kind of amperage, and that, you know, verifies that what we have is the amperage of the correct measurement. That is the running amperage on this system. Anyways, what we have here is, as I showed before, we have C1 and C2. This is C3 here. We don't have this connection on this test. This is from the first video. We just have the battery, and we have the battery connected to one gate, L1, and L2 is open on this test. So we're just cross-firing C1, C2, like it's a parallel connection with the two inductors. But again, remember, these are constantly swapping and pulsing because they reverse charges. So C1, C2 is collecting halfway on the reverse, on the collapse of the coil, and the other two comes from the input of the following coil set up at the commutators. Now let me reset these because I know they're gonna turn off in the middle of the test. I don't want that. So okay, so we got 2.708 starting voltage, and we're gonna first hook the battery to the motor. I have the commutators, the capacitors disconnected. If I touch it here, they won't do nothing. You see that? They won't move the motor. So they're dead. 230 something. So right now it's going 16.5. I'm gonna hook this on, and you see how it went down in power. And it's the load. It's charging up these two cabs, and you see how fast they start gaining charge. And this is amazing because right now it's showing, after I have done the repair on the 9 amps going into the system, and you see how much is filling up, and you hear the motor gaining speed, plus you see the tachometer. Yeah, it's working beautiful now. You guys see the speed is developing. Climbing up. They're already at 1 volt. It's at 10,000 now. And what's going on here is the caps are taking over the batteries. So the batteries are, in the beginning they do get the load, but then as it goes on, it keeps the caps start taking over. Then the battery circuit with that L1 coil starts coming down in amperage value because it's getting dispersed in the two side banks. See, right now we are at 1.27, 1.3. Actually, we're gonna enter soon, and remember the battery value was 2.6 something. So I'm gonna put the value of the battery. Well, we're climbing up the caps. We are at 13,000, 13.2. And we are already at 2.1 volts. So that means that value increasing also means the motor is taking less from the battery. It's what it shows. And the caps are taking over, running the motor. And the motor it's cool. I mean, it's not 98 degrees. Batteries are about 111 because they're getting a charge. Caps are cool. The two caps are. You see the caps are getting 1.5 already volts each. Now, once they get to 1.5, we're gonna break down the starting voltage we got. And we're already at 14.6 at the tachometer. So, and it keeps going up. It's already at 14.8 and climbing up. See, right now they are both caps already charged at 1.5 volts. So that means absolutely understandable that the motor is generating the charges to charge those two caps. And it's charging them above the battery level. And it'll be very simple to demonstrate by just taking the two caps off, adding them in series, and connecting a light bulb, the same light bulb, connecting it to the battery, and measuring amps on both and voltage on both. So we have to separate identities that, you know, we can take off, of course, the nickel and dimes that we started with, which was 240 millivolts. But hey guys, we are 1.566 now. And we are in 15,100 and counting up. We are 2.171 volts here. And yeah, I was losing a lot of heat on this contact here. So right now it's pretty warm, but not losing heat on there. So here, just with these two caps here, side crossfire and the coils that are constantly rotating and spinning and flashing on the sides. Now, this is flashing on the sides. We got some nice setup here. We are at 15,256 and counting up. Now, we are already at 3 volts something, 3.0 volts adding the two caps. And batteries consumption of the motor right now is 0.300 and something millivolts. So that's the motor consumption. That's the battery right there. And it keeps going up. Now, it's understandable that if I disconnect here, it'll keep running on the charges. But I don't want to do that. I want to take it to more charges on the caps. It'll keep running on caps only. And they will do decay right now, of course, because of, you know, we don't have the third video. We don't have the third video yet. So, but we will see the final end of this, where eventually we'll see them, the whole system together. It's already at 1.6 volts, and these caps are 310 farads and 2.7 volts. So they can take two volts easy. So, but this proves the generating capacity of this motor here. It's obvious. I mean, it's not much of 15,093 and counting up. I'm gonna disconnect it a little bit, and we see we keep going at 13.9 and we see them coming down, but now it's on complete caps. On the motor is running on the same voltage that it produced, that it generated, and that it put it on each cap. So, and the battery of course reflects a value that is gaining back. It's a starting value. I run it back up and it started increasing again. And so on. I just don't want to make the video too long. I want you guys to replicate this, and I'll put the exact values and of the caps, where I got them and all that, so you guys know that. But I find this amazing and very interesting, and you should give it a try yourself. I mean, replicating it and seeing it for yourself, that it's like this. But you know, I order a third cap that I supposedly have it here tomorrow. So anyways, you guys don't have count all the time, but so I can have the third video where I'm gonna have all three caps. All three caps. C3 is gonna be included as in the first video, plus these two caps running the whole system. Alright guys, so we got, again, back 1.5 volts each cap, 14,300 and gaining up. We got battery, motor is consuming 600 millivolts, I'm sorry. So yeah, I'm going to hook this, drop down about 1,000 RPMs, which is not bad. Not bad for the generation of the own motor. But I'm gonna disconnect it, and the battery is gonna keep climbing back. And the tachometer is gonna record the last reading of the caps running the motor itself. And we can see battery gaining voltage real quick, but I don't want to get this video too long. And absolutely, next video, number 3, I believe will be pretty interesting, as I want to see. You guys will be realizing why I call the first video, I call the center cap working in the second gate, I call it buffer. And this one right here, connected to the other L2 gate and L1 to the battery, this is a buffer, and the reason is that this is a buffer between these two guys, and you'll see what I mean on the following video. It's 2.456, and like you've seen in previous video, it will keep climbing up. I don't have to make this video such a long deal here. Thanks for watching, and just I'll let you know when I get it up. Thanks.